Shucks. Okay. Anyone got their list? Capsule. Capsule. That's this brown covering on the outside of your kidney. It's basically connective tissue for protection. What's next? Cortex. All right, as we saw in the book, this outer layer, which is kind of a light brown here, that's your cortex, whereas all of this darker area is your medulla. How do we separate the cortex from the medulla? No, the arcuate arteries and veins, remember? If it's blue, it's an arcuate vein. If it's red, it's an arcuate artery, but it makes an arch, and it separates the medullary region from the cortical region. Okay? Does that make sense? All right. What's next? Okay. Each of these is called a pyramid because somebody else thought it looked kind of triangular. And these pyramids are separated by, what's my next word? Is there a word column in there? See these? They call these the columns because they are going to separate each of these areas called the pyramids. What's next? Papilla. Okay. The papilla are finger-like projections, right? Every time we see papilla, like the ones that are inside your intestines and whatnot, what they're saying is that each of these, which are the ends of the collecting ducts that we drew on the board the other day, each of these is like little fingers, okay? So what we have here is papilla aiming towards you. So if you're looking at the answer key, they're saying this is a group of papilla right here. The papilla, those collecting ducts, are going into these dips called calyx. Now, these are called minor. That's a minor calyx, a minor calyx. Even that would be a minor calyx with the papilla on the inside. And where several minor calyces come together, that's a major calyx. You see how this one, and of course that one back there, all go into this opening? So that's the major calyx, and the rest of these guys are minor calyces for plural.
So is that papilla cut? They would be.
Well, yeah, they're not cut. They're just showing you little holes in between because that's what's sticking out at you. That's all. Okay. All right. What's my next word?
Renal pelvis.
Okay. Where all of these major, see, minor, minor, major. See, minor, minor, minor. That's a major calyx. That's a major calyx. Where all those come together is the renal pelvis. Because pelvis means basin or bowl. And it's going to collect all that urine from all these major calyces. And then it's going to go down this tube, which is the ureter. Okay. What else? Okay, a nephron is one of these working units, which means it starts with the round thing called a... No, the glomerulus on the inside, you can't see it. Bowman's capsule. Then we have our proximal tubule, loop of handling, distal tubule, then the collecting duct. Right? So one of those is called a nephron. Next word. Hello?
Renal arteries.
Okay. Renal artery and vein. The big one's going to the kidney. Renal artery and vein. And don't worry, all the arteries here are going to be red and the veins blue. It's only backwards into where? Lungs. Okay. What's next? Who? Segmental, right here. Those are your segmentals. In other words, the next branch after the main ones. Then? Okay. Interlobar, isn't it? Right? Not lobular, but lobar, right? Okay. That's these guys right here. They basically separate each of these pyramids. okay, into lobes. That's what's called interlobar, between the lobes. All right, what's next?
Arcuate.
Then we got our arcuates up here. And then, last but not least, cortical radiate. Okay. So that means they're going to be in the cortex, which is what? This area. And they're going to radiate out like rays of sunshine. Got it? They're radiating out into the cortex. That's all of these guys. Those are cortical radiate arteries, and the blue ones would be cortical radiate veins. Okay. Cool? Anything else?
Afferent arterial.
Okay. We're going to have to blow this up. All right? So that's the whole kidney at once. The next picture is going to be one of these pyramids. All right? So let me get to that. All right. Here we go. There's one slice out of your kidney. Let's see if we can go through each of these things. What were these blood vessels here? Interlobars. Very good. And what does this become? Arcuate. Arcuate, artery and vein. And what are these guys? Cortical radiate. Arteries and veins. Got it? They're radiating into the cortex. So that takes care of that. Once you look at one cortical radiate artery, do you see how this thicker blood vessel goes into my Bowman's capsule? There's your afferent arterial. And the thinner one is coming out. There's your efferent arterial, right? Or afferent and efferent. Does that make sense? And now we've opened up the Bowman's capsule to really see what's going on. Here is the afferent arterial coming in. That is the glomerulus, the tuft of capillaries in the Bowman's capsule. So here's my Bowman's capsule. What do you think this tube is? Proximal convoluted tubule, which then becomes the which part? Descending loop of Henle, then the ascending loop of Henle, then it becomes the distal tubule. Look, it comes back. See how close it is to my glomerulus? Because right here we're going to create the what apparatus? Juxtaglomerular apparatus.
But in reality, there would be like a little arterial right up beside that.
Where?
Beside the loop.
Yeah, I mean it's coming back out. That's it right there. Paratubular capillary. So, and then the distal convolutes and ends up going into the collecting duct. Right? Are we good? Let's review the functions. What's the function of the glomerulus? Filtration. What's the function of the proximal tubule?
Water return.
Reabsorption. What percentage of glucose is reabsorbed? 100%. What percentage of the rest of the filtrate is absorbed? 65%. Okay? Then we have the descending loop. What's its function? Reabsorb water. Then the ascending loop. Reabsorb salt. Then the distal.
Like funnel tweaking.
Well, not the funnel tweaking, it's secretion. Remember? We only have three functions: filtration, reabsorption, and secretion. So we're going to secrete from these paratubular capillaries any other metabolites or urea that we need to get rid of. Then last minute tweaking under the influence of hormones takes place along the collecting duct. Under the influence of ADH, aldosterone, and A and P. Very good. Very good. Test question. What is the Bowman's capsule made of? What kind of cells? Simple squamous. What kind of cells is the PCT made of? No, not simple squamous. Simple cuboidals with microvilli. It's all about absorbing. What is the descending loop made of? Simple squamous. What is the ascending loop made of? Simple cuboidals. What is the distal made of? Simple cuboidals with definitely no microvilli. What is the simple cuboidals? Some with and some without. Because we're going to do some absorption and some secretion. Okay? Very good. That pretty much covers all that. Well, tell you what. What kind of a nephron would this be compared to this nephron? What would this one be, most likely? Cortical nephron. What would this one be? That's right. This is a juxtamedullary, not JG, but JM. It's a juxtamedullary nephron because it has a very deep loop of Henle. Now, you see this blood vessel right here? That should be on top of a loop of Henle, but they moved it over to the side so you don't get confused. What is this that goes up and down on top of the loop of Henle? Vasa recta, the straight blood vessel. Got it? And there it is, going all the way down to the medulla, just like this. What is the function of this juxtamedullary loop of Henle?
To conserve water when you're dehydrated.
Exactly, to conserve water. Okay? And therefore, since we usually aren't living in the desert dying of thirst all the time, what do we have more of?
The corticals.
How many?
2 million.
No, remember the number? What percentage?
Like 80 to 20 or something.
I think it was 80, 85, 15.